Alrighty, so let's go ahead and get started. Thank you all so much for coming tonight. It's such a pleasure to get people out learning about streams and why they're important. My name is Carolyn Klauba. I'm the Stewardship Director for the Sourland Conservancy. And I want to do a little introduction, tell you about the Sourlands and the Sourland Conservancy before we get started. So the Sourland Conservancy is a nonprofit organization dedicated to protecting, promoting, and preserving the Sourland Mountain region. And the Sourland Mountain region is an area in central New Jersey. It spans Hunterdon County, Somerset County, and Mercer County, and it's the largest contiguous forest in central New Jersey. And it's really, really important for many bird species, migratory bird species. It's really important for land mammals and for aquatic organisms. And what you're going to be learning today is about stream monitoring and stream health and why it's important. When you are in the Sourlands, you'll notice something that's really special about it, and it has these really big diabase boulders. And these diabase boulders make it really hard for water to infiltrate. So we have all these wonderful perched wetlands and these streams. And the Sourlands has about 17 headwaters that feed into streams that empty out into the Delaware and Raritan rivers and provide clean drinking water for millions of people. And what's going inside those streams is really critical to our understanding about how healthy those streams are. Inside the streams are aquatic macroinvertebrates, and they are the storytellers of our streams. They let us know what is happening. There are ways to go in and take a water sample out and have a chemical analysis, but that only tells you what's happening in that very moment. But what you're going to learn about in your program tonight is about when you collect all the information, whether it's habitat assessment and biological assessment, when you collect the macroinvertebrates, that tells you the actual story of what's happening in that stream, from the biological community that's there and the habitat around it. I know sometimes it can seem really overwhelming getting all this information thrown at you, but it's sort of like somebody telling you a recipe to a cake versus making the cake. When you actually get out into the field and you do it, it's so much fun and it's really awesome. So tonight we're going to go through the nitty gritty, and then when you get out in the field, it's a ton of fun. So with that, I want to introduce Amanda. She is going to be our Watershed ambassador of the evening, and she's going to talk to you all about how these assessments are done, why they're important, the things that affect water quality. And then if you have questions, what I'd like you to do is drop them in the chat and we can address them later on at the end. Otherwise, it gets a little choppy trying to stop and answer questions as we go along. So please keep yourself on mute. And with that, thank you, Amanda, for being here.
Thank you, Carolyn. That was perfectly said. I definitely agree. I think it's going to be a lot of information thrown at you tonight, but once we get out there on Saturday, it's going to be a lot of fun and it's going to be easy peasy and it's just a great time. So I'll get my PowerPoint up here. We did figure out how to use the laser, so this is great. All right. Okay, so today we're going to be learning about the biological stream assessments that the AmeriCorps New Jersey Watershed Ambassadors do for the program. So again, my name is Amanda Wygand, and a little bit about me. I live in Robbinsville, New Jersey, so not too far. I graduated from Ursinus College last May, and right out of college, I applied to be a watershed ambassador, and I'm so lucky that I got it, and I've had this opportunity to be a watershed ambassador. I graduated with an environmental studies major and a biology minor. So what is AmeriCorps? AmeriCorps is a national service program that improves the lives and foster civic engagement. So the goals for the New Jersey Watershed Ambassadors program, we promote watershed stewardship and we monitor the stream health. So with watershed stewardship, that includes cleanups, tree plantings, rain barrel workshops, rain garden workshops, all for the communities and also doing presentations to schools, organizations, any type of group like libraries. We do presentations on non-point source pollution, teaching people about what a watershed is. We do composting presentations, macroinvertebrate presentations, anything that you can think of, we are doing watershed stewardship. And then with the monitoring the stream health, we do the visual and biological assessments. And there are 20 watershed management areas in New Jersey. They are all around the state. And the people who are in the program serve as watershed ambassadors for their watershed management area, or WMA. So before I get too deep into it, it's really important to know what a watershed is. So this slide is in every presentation I give because it's so important to know what a watershed is. So this diagram, I find it to be the perfect diagram that just shows everyone what a watershed is. So it is an area of land that drains into the same common body of water. So all of the streams, brooks, creeks, lakes in our environment, and including groundwater, the infiltrated water that leads out into, it goes through the ground and then out into some type of body of water. All of those lead out to a common body of water. So they all lead out to one place, and it's defined by the regional topography and elevation in the land. So all the water moves downhill. A watershed always goes downhill and it drains out into a body of water. So here are the 20 watershed management areas in New Jersey. So I am located in 11, watershed management area 11. So that is right here along the Delaware River. It is called the Central Delaware because we are very central and it's along the Delaware. So here's just a closer look of what watershed management area 11 looks like. So all of the streams in WMA 11 lead out to the Delaware River, which then in turns either leads to the Raritan River or to the Delaware Bay, and then out into the Atlantic Ocean. So the main problems in just about every watershed in New Jersey is non-point source pollution. So non-point source pollution includes litter, oil on the streets leaking from cars or tractors or any type of machinery, animal waste, pesticides, fertilizers, all of those that are on impervious surfaces such as sidewalks, roads, parking lots, all of that, when it's on those types of surfaces, when it rains, it's not seeping into the ground, it's causing runoff. And all of that runoff leads into our storm water drains, and the storm water drains lead out into our streams and lead out to our Delaware River and then into our ocean. So it's this whole effect of all these types of non-point source pollutions entering our waterways because there's so many different factors to it and so many people have a hand in it. So it's hard to point out or focus on an area that could be having a lot of pollution because it's coming from a lot of different factors. So what can we do to protect our watershed? Attending watershed stewardship activities. So going to education events, such like this one, restoration projects like tree plantings or stream cleanups, beach cleanups, and then also just changing personal behavior. So conserve water, take shorter showers, clean up after your pet once you take them outside to go to the bathroom, reduce your fertilizer and pesticide use. You can try to use natural alternatives, pick up trash or litter, properly dispose of household chemicals, and reduce your amount of waste you produce. So no single-use plastics. I find the easiest thing to do is get a reusable water bottle. I know a lot of us environmentalists, we have one of those. So all of these are just really easy ways to take steps to reduce your carbon footprint. So how the ambassadors monitor the effects of human impact. So we do the visual and biological assessments. So with the visual assessments, that involves going to the streams and just taking a look around. So we look at the canopy cover, the turbidity of the stream, if there's litter presence, we look at how wide the riparian buffers are, if there's houses close by, if there's roads paved or unpaved nearby. So we just take a look at the surrounding area. And then we also take depth, width, and velocity of the stream. And then for the biological part of the assessment, that involves collecting and identifying the benthic macroinvertebrates. So that is what we are going to do on Saturday at Stony Brook in Rosedale Park. And these benthic macroinvertebrates are indicators for water quality. All right, we're going to get into it, the biological assessment. So we're going to break down the word first, benthic freshwater macroinvertebrates. So benthic just means bottom dwelling. And then freshwater obviously means not in salt water like the ocean, so found in streams, lakes. I'm getting internet is unstable connection, so hopefully we're still doing good. Okay, awesome. Hopefully I don't cut out. All right. Macro means that it's large enough to be seen with the human eye. So we're not looking at micro, we're looking at macro. And then invertebrates, so organisms without backbones. So when we're out at the Stony Brook, we're not looking for fish or frogs or salamanders. We're looking for the guys without backbones. So why are we looking for macroinvertebrates? They are long-term stream residents. So we are mostly looking at the macroinvertebrates in their larval form. So most of them are flies. So once they are in their adult form, they will not be in the water anymore. They will obviously become flies and lay their eggs in the water, and it starts that whole life cycle. So they're long-term, they're stationary, so they're easy to collect. And there's established protocols for collection, and it's understandable for the general public to learn and to catch them. They're also indicator species. So there's that pollution tolerance value of 0 to 10. So this tells us how much pollution an organism can withstand before dying off. So if there's a lower tolerance, that means there's less pollution that it can withstand. So here's kind of a chart of the high pollution tolerance to low pollution tolerance. So if we're in a stream and we're seeing a lot of worms or leeches or blood red midges, we know that that stream could be considered a high pollution tolerance stream because we're finding a lot of these macroinvertebrates that can withstand these types of pollutions, these non-point source pollutions in the water. But if we're finding a lot of mayflies and stoneflies, that's a pretty good indicator that the stream is healthy and there's not a lot of pollution in it. So when we're at the stream, we definitely want to see a whole range of, ranging from low to high, because that means that it is a really good ecosystem and all of these macroinvertebrates are living in it. But if we're finding, again, just those higher pollution tolerant ones, and we're not finding any mayflies or stoneflies or case builders, then that's a good indication that the stream is not doing too good. So I just wanted to put a picture of what our data sheet is going to look like on Saturday when we go out there. This is what the data sheet looks like and that all the ambassadors use when we're at the stream collecting macroinvertebrates. So we will collect and we will find 100 macroinvertebrates. And I know that may seem like a pretty big number, but you'll see them and they'll come by quickly, and we'll get to 100 pretty fast. So this is the chart. Once we find each one, we put a tally in the tally column. And then, once we get to 100, we count them and we put our numbers in each in the count category. Okay, so just a little bit about insect anatomy before I get into identifying them. You'll hear me say some of these words, so just so you're aware. So obviously they have to have a head, and then the thorax is the part of the body that's right below the head, and then we have the abdomen of the macros. They will all have abdominal gills, and the fly ones will have wing pads. Sometimes the wing pads are hard to see, especially in person, because sometimes they're so small, it is harder to see. And then we have jointed legs for some of them, and then tail filaments. And we also have some prolegs on some of them. So they're not large legs like these ones shown on the mayfly. They're little tiny nubs. So some non-insect types of benthic macroinvertebrates, we have crustaceans such as crayfish. We have the worms, leeches, and snails and clams. Alrighty, so now we are going to get into the nitty-gritty part of learning each macroinvertebrate. So feel free to just, if you want to take notes, on Saturday, I have a lot of dichotomous keys, they're called. They are going to help you identify the macros when we are out there. But if you would want to take some notes, feel free. It's not necessary. But if you wanted to write down anything and bring it out there on Saturday to help you identify anything, feel free. So first up, we have our mayflies. The mayflies are my absolute favorite. They look like little aliens. So that is why I think they're so cool. So they can be between 1/4 to an inch long. They have well-developed eyes, and their eyes are like right on top of their head. That's important to know to tell the difference between mayfly and the next one we're going to talk about. They have 3 pairs of segmented legs, and their legs have 1 tarsal claws at the end. They're called toes. They have developing wing pads. So on this picture here, this right here is 1 wing pad, and this right here is the other wing pad. So like I said, it's kind of hard to tell. So the wing pads aren't that important to know when identifying. But for the mayflies, when you see them, you're going to look for these gills along the side of the abdomen. This is going to be the best way to identify a mayfly is these gills on their abdomen. And then another way you can tell is that they're going to have 2 or 3 tails at the end of their body here. So here's just a couple of different types of mayflies that you could see out in the stream. So you can see they all have the same shape to them, but they just all look a little bit different. So that you can see the jointed legs, the wing pads on each of them. They have those gills on the sides of their body, and then all of these have the 3 tails at the end of them. So here's some pictures of what they could look like in person. So again, here are the gills on the abdomen. We got the 3 tails. This one looks like a swimmer because it looks like the tails are really close together. This one kind of looks like it would be a clinger because the gills are almost like little hairs, so that when they're on rocks, they stay as close as they can to the rock and they're clinging to it. Just some more pictures of what they could look like. So again, those 3 tails, you can see the gills on the abdomen. That's how you're really going to identify them, is the gills and those 3 tails. Sometimes they may have 2 or 1. Sometimes they get picked off in the process of living or scooping them into the net. They can survive with just 2 or 1 tail. So you may see that too while we're out there. More pictures. You can see these big eyes on their head. Okay, so our next one is the stonefly. So the stonefly looks pretty similar, right? So we have the widely separated eyes. So the eyes aren't on top of the head, but rather on the sides of their heads. So that's another difference of them. They can be a half to 1.5 inches long. The way I like to identify it is the stoneflies kind of look like they're wearing armor. And when I think of armor, I think of stoneflies. That's kind of how I identify the stoneflies. So they have the 3 pairs of segmented legs, just like the mayflies. But the main difference between mayfly and stonefly is the stoneflies have their gills underneath their arms. So it's also known as hairy armpits, very scientific. So you can see their gills under each leg here. So that is where their gills are. And you notice they're not on the abdomen. So that is the main distinguisher between the mayfly and the stonefly. And then the stonefly ends in only 2 slender tails. So they're not going to have 3. They might have 1 because they lost a tail, but the stoneflies will ever only have 2. So here's another close-up picture of what the stonefly looks like. So you can see those gills right on his segmented legs here. He's got very hairy armpits. These are the wing pads here. But see, this kind of looks like armor, right? So that's how I remember stonefly. And then, you don't see any gills on the abdomen here. More pictures of what they could look like. So, they're brown in color. I think I have this next one. Oh, this one's a fun one. I've actually seen this guy out in the streams. This is called a roach stonefly because it looks pretty much like a roach. You can see he has double gills. So they're just 2 kind of little gills hanging off of his arms. This one. So this one's huge. This one's a big stonefly. It looks a little lighter in the picture, but I've seen them where they're almost black. So, they're ranging from a dark brown with a bit of coloration in it to a very dark, almost black color. So you can see his gills here, right there, and his beautiful wing pads. All right, on to our damselflies. We may see a couple of these out there. So damselflies are pretty tiny, so they could be a 1/2 inch to 2 inches long. The main distinguisher between the damselfly and the 2 other ones we just talked about, the damselflies have a grasping mouth part. It's called a prehensile labium. So just imagine your arm being your bottom lip and just extending it out and catching your prey and bringing it back in. So there's a picture down here of kind of how that jaw extends out to catch prey and then sucks it back in. And then here's a underneath picture of what the jaw looks like. It's pretty big. So that's the damselfly. They have the 3 pairs of segmented legs, the wing pads. They do not have abdominal gills. Their gills are actually on their tails. So they have paddle-like gills. The paddle-like gills look like tails. It is its gills, but we do just say tails because it looks like tails, but that is how they breathe. So I think, so here's just some different variations of what they call, and they don't move. So when you scoop, when you are out there and you take a scoop of it and you're looking in your scoop and you're looking for damselflies, they're not moving. They're kind of just chilling, and they come up out of nowhere. You could pick up a leaf and be like, oh, there's a damselfly on it. So they're very slender, thin, just chilling. They're not there to freak you out or anything. Let's see. I think here's a nice picture of it. Yeah, very thin, and you can see those paddle-like gills at the end here. So this one, it doesn't look like they have a paddle-like gills at the end. It's not the case all the time, but so yeah, like this would look like a mayfly perhaps because you see the 3 tails, right? But when you're identifying it, you don't see the gills on the abdomen. So you would count this as a damselfly because you don't see gills on the abdomen. You don't see gills on the segmented eye because the gills have to be right here. Here we go. Some more pictures. Here's those paddle-like tails. So you can see this one's just slightly more thinner than this one, but these guys look like little aliens too because their eyes are like on the sides of their heads too. But the distinguisher is these paddle tails. Okay, so here's just a chart of the difference between the three we just talked about because they all do look a bit similar. So our mayflies, they have the gills along the abdomen. That's your main identifier for those, as opposed to the stoneflies. The stoneflies don't have abdominal gills. Their gills are along their thorax, underneath the arms, so hairy armpits. And the one thing I like to identify them, they look like they're wearing armor, right? Armor, stoneflies. Just think about it that way. And then our damselflies, they have those prehensile labiums. So they have a big mouth part that reaches out and sucks their prey in. And their paddle-like tails at the end of their body are their gills. So you won't see gills on the abdomen or the thorax on the damselflies. Okay, on to our dragonflies. So these guys, they are a 1/2 inch to 2 inches long. They also have the prehensile labium, so it reaches out, sucks their prey back in. So the main thing you're going to look for when you're looking for the dragonflies is their 3 wedge-shaped spikes at the bottom of their abdomen here. So that is how we identify them. And they're usually more bulbous in shape. They're not thin or slender. They're pretty hefty, pretty bulbous. So here's some pictures of what they look like. I think they look like fat spiders. So that's how I like to identify them. Yeah, their abdomen can be quite bulbous. So just look for that shape and those 3 spiked tails at the end, and you have yourself a dragonfly. So here's a picture of the difference between a dragonfly and a mayfly. So here you can see the prehensile labium. It's very large. And then on the mayfly, you don't see that at all. They don't have the prehensile labium. So you don't see a large mouth part at the bottom of these guys. And you can see the difference here. It has that bulbous abdomen while the mayfly has a very slender body with the gills on the side. Some more pictures of just the different variations of dragonfly. So this one's a pretty big one where it is still bulbous, but a little bit more slender, while this one's just, this one is just very bulbous and round. Some more pictures looking like scary spiders almost. Yep. So yeah, these are definitely darker in color. This one I think is a very great picture and very high quality coloration. All right, on to our case building caddisflies. So the case builders can be a 1/2 inch to 1.5 inches long. They're caterpillar-like. They have segmented body. So they have 3 pairs of the segmented legs. And then the main part about the case builders is that they have a hardened shell on their thoracic segment. It's 1 to 2 ways down on their thorax. So here in this picture, this one only has 1 hardened shell along the thorax. And then the abdomen, they don't have a tail, ends in a pair of prolegs, each with a claw. And Some other thing you would see with the case builder is that they could be found in a constructed case. So you could find them like this, or you can find them inside of their case. And I'll show you some pictures of what that could look like. So here is what they would look like without a case. Sometimes we just call these caddisflies because they're free living. They're not in a case. They are not building a net either. And we'll get into net spinning caddisflies after this one. So sometimes we just call these free floating caddisflies, but we count them with the case builders. So you can see here, this one only has one hardened segment here, while the rest is not hardened. And then you can see the three segmented legs. A lot of the times you could see a green case builder. So you can see it's kind of almost hairy. These are its gills here. And then this one, so the difference between this and the net spinner, you'll see the net spinner has a very fluffy butt. So here you can see at the end, it's just the pro legs. It's nothing at the end besides its little legs. Just some more pictures of what they could look like without their case. Again, just free living caddisflies. So here's what their cases could look like. They look like cigars almost. And the reason why they have that first or second hardened shell is because when they are coming out of their case, they're using their pro legs to then crawl while they're dragging their case behind them. So while they're only out a little bit, their back needs to be hardened because the rest of their body is hiding inside of their case. So these are really cool to see, especially if you get a scoop and you just see something moving and you're like, what is that? It just looks like a stick or something. It's a case building caddisfly in its case, moving around trying to figure out why he is not in the stream. Here's what they could look like on rocks. So these are the cases that they build here, and they use anything they can find on the bottom of the stream floor. So sand, little pebbles. I've seen pictures of them putting little plastics on their cases too. So it's really cool how they build it around their bodies. So on to our net spinners. So these are the brother or sister of the case building caddisflies. So here you can see, like I mentioned, they have that fluffy butt at the end. So the net spinners do not build cases like the case building caddisflies. Instead, they spin nets. Net spinning, they're spinning nets. And they spin the nets on the rocks to catch food. So they are pretty similar, except for the fact that instead of having one or two hardened plates, they have three hardened thoracic segments on their bodies. Because they don't have a case on them, they need to have a bit more protection on their thorax here. And then they have that bushy tuft at the end, that's their gills. Again, we just kind of call them fluffy butts because it looks pretty fluffy. And then their gills are all along here. Their gills are underneath of them. So when they're swimming around, you can see them moving, and it's really, really cool. So here's a picture of their net that they build, almost like a spider web. They're really cool. When they're on the rocks, you can see the little silt that they make their nets out of, and they catch their food that way. So here's what the case builders look like. They're sometimes green, so they're pretty obvious in color that way. So if you see a green macro floating around and you can see the tufts at the end of the body, you can say that is the net spinner. So you can see their gills here and here, those hardened plates and the three segmented legs. And the webbing that comes out from these parts here, the fluffy ends. of their body. Again, here's another picture of the webbing and the nets that they make when you see them on a rock or anything. And here's a really cool picture of just a bunch of nets on the ground there. All right, so the difference between the two, we have the case builder. The case builder has 1 or 2 hardened segments on the thorax. You can find them in their case. So you'll know when it's in a case, it's moving around and it may look like a stick moving. But then you might see its little legs trying to move its body around. So if it is not in a case, the main difference between how you're going to tell if it's just a free living caddisfly or a net spinning caddisfly, you're going to look for that fluffy butt at the end, the tufts, because that is going to be your perfect indicator to tell the difference between the net spinner and then a case builder that is not inside of a case. On to our lovely hellgrammites. These guys are very scary. That we may see them out there on Saturday. So the hellgrammites can get up to 3/4 to 4 inches long. They're also called Dobson flies. I prefer to call them hellgrammites because I think that's just a really cool word to describe these suckers. They're very scary. They're large, powerful chewing mandibles. So if we do find one, we need to be very careful with them because those chewing mandibles can pinch you and it's gonna hurt you. I have not been pinched, but I don't want to be. I don't think you do either. So these ones, they're usually black in color. So you're gonna know when you see this hellgrammite. You're gonna know it's a hellgrammite because it's gonna be large and in charge. So it has 8 pairs of lateral filaments on the abdomen here. So these aren't legs, they're just filaments to help them swim and move around. And then at the end, they have a pair of short, tiny pro legs. So you can see here with a pair of hooks at the end. So this is what these pro legs and then the 3 pairs of segmented legs are what are helping them move around. And these are just filaments. So here's some lovely pictures of the hellgrammites. Yeah, large and in charge and scary. So yeah, I wouldn't want to hold it like that because it's pretty close to those little chewing mandibles that can pinch your fingers. So I mean, they're definitely cool. They are cool. But just scary, really scary. So here's their gills. You can see really well here. They're underneath of their body. So here you can't see them that well. They're like under each little filament there. But sometimes they could be really fluffy like this one. See, that makes it look a little less scary, but they are, I'm telling you, they're scary. So here's it next to a dime. So you can kind of picture what size this one would be. Okay, and then this is the elderfly. This is the cousin of the hellgrammite. I have not seen a lot of elderflies out in streams, but they're very similar. They don't have those chewing. They do have powerful chewing mandibles, but they're not as big. They overlap, actually. Their little mandibles overlap. They have the 3 pairs of segmented legs. Instead of having 8 lateral filaments like the hellgrammite, they have 7 pairs of lateral filaments. And then they only end in 1 long single filament at the end. So that's another difference between the hellgrammite and the elderfly. The hellgrammite had the 2 pro legs at the end. This elderfly just has 1 long filament. So here's a better picture of what they could look like. So you can see their mandible here, but it's not as scary looking as the hellgrammite. And then their filaments here, only 7, not 8. All right, the difference, here's our chart. Like I said, elderfly has the one long filament at the end. They're usually a little lighter in color too. You can definitely see the difference in color here. They are also smaller, so they're only a half an inch to 1.5 inches, while the hellgrammite can get up to 4 inches long. The hellgrammite is black in color, large and in charge. You're gonna know when you see a hellgrammite. Trust me. So just some more pictures of the difference. So hellgrammite is a bit fatter and wider, while the elderfly is definitely just more slender and thin. And then it almost like leads out to just one little filament at the end, which it does. All right. Our riffle beetle larva. So we identified because the adult actually still stays in the water. So we'll get into the adult in the next 2 slides. So the riffle beetle larva, they are very small, only 1/8 of an inch to 1/2 inch long. They are hardened, stiff body with a head. They're segmented dark brown or black. They have 3 pairs of segmented legs, and I have not seen a lot of riffle beetle larvae, so I'm not sure if we'll see any out there. They're going to be really small also, so it might be hard to identify them, definitely. So they almost look like little commas when you're out in the field. That's how tiny they are. They could be. But their whole body is segmented. So that is a good way to tell that it's a riffle beetle larva because of the segmented body. And then those 3 3 segmented legs, not pro legs. So this is the riffle beetle adult. So any type of very small beetle that we see out there is going to be a riffle beetle. They're so small, only 1/16 to 1/8 inch long. Very small, hardened body, usually black in color, and 3 pairs of jointed legs. So if we're seeing anything bigger than 1/8 of an inch, we don't count them. They're probably just some type of other beetle species. So these guys are pretty easy to identify because they're small, and they're black in color, and they're little tiny beetles. Onto our water penny. So we call these the cows of the streams because they just stick on rocks and they graze the rocks and eat all of the little microorganisms that are living on the rocks. So they can get up to a 1/2 inch long. They resemble a penny because it adheres to the rocks or the surfaces of anything that it's on, and it camouflages itself. So it has a distinct head, thorax, abdomen, and gills on the underside of it. So you can see that all right here. So there's its gills, its legs, and its head. And this is what it's going to look like when on the back side of it. So that's how we see them because all of their insides are underneath of them. So a water snipe fly, these are very hard to find. When we were getting taught the ambassadors about all of the macroinvertebrates, we were told that we're never going to see any of these. And we have found them occasionally, but I don't know if we'll see them Saturday. Maybe we'll get lucky. So these are water snipes. We also just call them snipes. So I bet you think that this side is the head, but that little thing there is its head. So it can get up to 1 inch long with a segmented body. It has that tapered tiny head that also retracts in so it can pop its head out and then also suck it back in. So it has several pairs of prolegs on the underside of the body, so you can kind of see them here. And then they have 2 hairy appendages at the end of their body here. So here's some pictures of what they could look like out in the stream. So that's its little tiny head here. Definitely looks like the head should be on this side and those are like antennas or something, but nope, it's behind. You can see its little pro legs there and there. Almost looks like a worm, but with legs. A plumpy worm, plumpy for sure. So there's its little head there. And yeah, that is the water snipe. Haven't seen them in a while. Crane flies. The crane flies are the best besides the mayflies. These are plumpy macros. They can be a third to 2.5 inches long. Plump, segmented body. Their head is round, sometimes retracted, but the one thing you're going to notice is the fleshy finger-like spiracles on the posterior of the body. So they kind of look like that, just moving around. It helps them move and groove in the stream. These lovely crane flies, plump, large, and in charge. These guys are really fun to see when you take a sample and you see it in there and it's like moving like a worm, and it's just really gross but really cool at the same time. These guys are cool. Here's some more pictures. These ones are light in color. I haven't seen a light crane fly like this. They're usually much darker, like this, like the browns and the blacks. How we doing on time? Perfect. All right, black flies. These are not good. These macros are the pollution tolerant macroinvertebrates. So we may see some black flies out there, and that's fine. If we're finding mostly black flies, then that's not good. But I know we won't. We'll find some other ones too. So don't worry. So they have a distinct hardened head. They have a single proleg directly under the head. And how you'll identify them is their bowling pin shape. And when you take a scoop, you'll see that the posterior of the body is going to attach itself to the sides of the container, and it's just kind of gonna float around, and it's gonna move its little bowling pin body around and try to catch food and try to figure out where it's at and why it's in a container. So yeah, here's a great picture of what I'm talking about. It'll connect itself at the posterior and just kind of float around and want food or something. I don't know what the black flies do, but here's its little proleg here underneath its head. These guys are pretty easy to identify because of their shape and how they attach themselves to the sides of the containers. So yeah, they're usually black in color, and they are small, but they're easy to identify. And then our midge flies. So these, they can be 1/8 of an inch to a 1/4 inch long, so still very tiny. They're almost worm-like, but their head is hardened. They have a very small pair of prolegs between the heads. You can see that here, and then at the posterior of their body here. So they're usually light in color or red. So it's a very bright red. You'll know when you see that color. We can also find worms that could be that color, so that might be a little tricky identifying them. But the way they move too, they almost kind of just like fling themselves around, whereas a worm would kind of just move like a worm. So here's what they would look like, midge flies. They are tiny and thin, but they kind of, like I said, just move around like this, like they'll just sporadically move. So that's how we kind of identify them. And then when we do pick them up with either a pipette or a spoon, we can see, we can identify the proleg and their prolegs and identify it as a midge. There's just some more. Onto our scuds here. I think we'll find some scuds out in the Stony Brook. So the scuds look like little shrimp. So they're laterally flattened. So they're side swimmers because they're laterally flattened. So they swim just like how it's pictured here. They're just gonna swim sideways and not forward. So they have 2 pairs of long antennas, and then 7 pairs of segmented legs. So these are very easy to identify because they just look like shrimp. And then the cousin to the scud is the sow bug. These are dorso-ventrally flattened, so they're not laterally flattened. So they're from top to bottom like this, as opposed to the scud where they're flat like that. So they have deeply segmented bodies. So each one is very indented. They have the 2 pairs of antennas, just like the scud, and the 7 pairs of segmented legs. But they have an enlarged final abdominal segment, as you can see at the bottom here of this sow bug. So here's the difference between the two. The scuds, they just look like shrimp. That's the best way to identify them. And they are side swimmers. So when we take a sample and we see a scud, you're going to notice how they're swimming, and they are very quick. So you'll see that they're swimming sideways and not like normally. While the sow bug would swim normal, they're dorso-ventrally flattened, and they have those deep segmented body. And our crayfish, we are most likely going to see some crayfish at the Stony Brook. We're probably going to see invasive crayfish, which stinks, but we'll still see them. So these ones, very easy to identify. They look like little mini lobsters, right? So that's the best way to identify them. They have the head and thorax are fused together, and they possess 5 pair of legs, and their first pair being huge pinchers. So also want to be careful not to get pinched by these guys. Little lobsters, we got our crayfish. All right, and then on to our leeches and worms. So leeches, they have the flattened segmented, it's a flattened segmented worm, and then they have a sucker on both ends. And then our worm, it's very flowy, worm-like. These are easy to identify. Here's our leech, beautiful. And our worms, just beautiful. Onto our clams. Obviously, clams are easy to identify. They have the 2-piece shell with a hinge that opens up. So if we are taking a sample and we are just finding one shell, we're not counting that because that clam is not alive, obviously. We may see some shells out there. I don't think I've collected clams at Rosedale, but I have seen shells. So I know the clams are in there. And then we have our snails. So we have 2 different types of snails, actually. We have our lunged and our gilled snail. So the best way to remember the difference between the two, so the lung snail, the opening of the shell is on the left side. So left lung. That is how we were taught. And that is, I think, the best way to obviously remember it. So the shell opens up on the left, and the operculum covers the shell opening to keep the air inside. So these are lunged snail. While the gilled snail, the opening of the shell is on the right. So right goes to gilled. So opening on the left, lunged. Opening is on the right is gilled. Gilled is good. That is why. The gilled is good. So that is the right side opening, left side lunged snail. Oh, and here is a video. I did throw this in here. Here's a video of all of the macros that I had found in this one particular day in our ice cube trays. So I'll get into a little bit more about how we're going to put the macros in these ice cube trays, but I just wanted to show you what, a final product could look like at the very end of our stream assessment. Oh no. Play again. Here we go. So you can see they are tiny. And then we got some bigger guys there. Yeah, so there was some black flies in there, some stone flies at the very end. Those were the bigger ones. There was a worm, a riffle beetle. So you probably may have watched and been like, what did I just watch? What were those little tiny things? In the beginning, I noticed those two bigger ones. The bigger ones are obviously easier to identify because they are bigger, but we do want to account for those smaller macroinvertebrates too. Okay, so here is our dichotomous key. So I will provide you all, I have a few copies of a dichotomous key. This is what's going to help you identify those macroinvertebrates. So you're going to start by just looking at a macro and you're going to say, how many legs does it have? Does it have 6? Does it have 10, 2, whatever? So you're just going to follow each one. If there are 6 legs, you're going to say, yes, there's 6 legs. Does it have a piercing or needle-like mouth point? You're going to identify it like that. You would say yes or no. If you went to no, does it have a portable case, like a case building? You would say, yes, it does. And then you'd get yourself a case building caddisfly right there. So that's kind of how you would identify it. I have lots of different ways that we can look on our dichotomous keys and figure out what macro we are looking at in real time. Okay, so now we're gonna finally get into how we are going to scoop and look for these bugs, besides me just talking about all of them. So we have different types of locomotion for the macroinvertebrates. So there's the skaters, the clingers, the crawlers, the climbers, the swimmers, the sprawlers, and the burrowers. So when we are in the stream, we want to account for all of these types of macroinvertebrates. So the skaters, they usually skate across the water. Those are usually water striders. We don't count those. We may see them though. We have the clingers, like the water penny, where they just are sucked on to that rock and just filter and just eating everything as they walk along the rock. So when we pick up a rock, we want to scrub it really well because we want to get those water pennies off of the rocks. The crawlers, so they may be the mayflies. They could just be crawling along the rock. So when we are, on the rocky bottom of the Stony Brook, we're going to move around with our feet and kick up rocks in front of our net. So that way the water is going to wash all of the macros that we are catching by moving around the rocks into the net. Swimmers. So just going under woody debris. That could just be hanging, like the macros that are hanging out in the woody debris. We want to make sure we're getting a scoop there. Burrowers, just getting into the sediment of the bottom of the stream by moving our feet around. We're going to get those burrowers. So like the clams or what other ones are burrowers? I think mayflies can be burrowers. I'm going to stop saying that word. All right, so here are the 4 places where we're going to be scooping. So the riffles. So wherever the water is hitting the rocks and it's creating like that riffle sound, that is creating oxygen in the water. And that is where you're going to find a lot of macroinvertebrates because they need oxygen. So we're going to collect in riffle areas. The woody debris or vegetation, if there's vegetation in the water, we're going to scoop there because we have those crawlers or climbers that are hanging out in the woody debris and vegetation. Undercut banks, perfect spot too. We're going to get our scoop under there, our net under there, and scoop under the undercut banks. And then in the sediment too, when we're kicking up rocks and just making sure we're getting deep down into the sediment with our feet. So that way all of the macros can come up and go into our net. So here's just some pictures of what I'm talking about. So here's like woody debris that we find some macros on right here. Leaf packs, usually in riffle areas. A lot of leaf packs collect. That's also another spot where you want to just like get the leaf pack in the water and swish it around, and that'll get all of the macros out of the leaf pack and into our net. Cobble riffles. So again, right in those riffle areas, those macros will be hanging out. And then vegetation too. Let's see how much time we got. 30 minutes. I think I'm good on time. So luckily, Rosedale, the Stony Brook is a really great stream. It does almost look like this because there are a lot of riffles because of the rocky bottom. So that is a better indicator for a stream with riffles because it creates that oxygen in the water for not just the macros, but for other living things that are in the water as well. So if we're seeing a stream like this, we could say that this stream doesn't have a lot of diversity because it is very eroded. There's not a lot of rocks you see. The depth is uniform, lots of sediment, no pools or riffles. But so luckily we won't be going to a stream like this one on the left. We will have a pretty good stream on Saturday that is going to give us lots of macros. So just some stream morphology. So when there is a riffly area, there is that run afterwards where the water is flowing a bit quickly, but then as it's getting away from the riffle area, you start to get a pool. So that could be a slow, deep pool. And then we have the glide. So sampling techniques, here we go. So we're gonna locate a riffle, or this is the fun part here. The riffle areas, those are just the most important because it's creating that oxygen for the macros. So we're gonna locate a riffle and we're going to face our D nets upstream. So, and then we're gonna place the net level to the bottom of the stream, okay? So then we're gonna pick up and scrub the rocks with our hands. If the water's not too cold, feel free. We're gonna pick up the rocks and keep it in the water, and we're gonna rub the rock like that and get anything that's off of the rocks. And all of it is going to wash into the D net. So this could be good for a partner. Someone could hold the net in front of you while you are getting that rock and getting everything off of that rock. The other option is to hold the net in front of you, and then you're going to kick the substrate up for 45 to 60 seconds. So we like to call it the macro dance. We're just kind of swishing around in the water with our feet and kicking up the rocks and just getting our feet into the sediment and making sure we're disturbing the ecosystem there so we can get those macroinvertebrates out and into the net. So those are just some ways to get the macros in a riffle area. So then once we have our macros in our net, we are going to then put them in a sieve bucket that we have that lets water in the bucket while also keeping the macros in the bucket. So we get the net, we invert it, and we put the macros inside the bucket. And we're going to do this process in 10 locations. So it gives it a nice representation of a 100-meter stretch. That is the amount of space that we're going on. We're going 100 meters, and in that 100 meters, we're going to scoop. We'll probably scoop more than 10 times. We as ambassadors usually do anyway. But 10 is the protocol. We could go over. It is okay if we do. scoop that 100 meters, and then we go back and identify the macroinvertebrates. So then at the very end of the stream assessment, you've got to 100 macroinvertebrates. The most important part is to decon at the very end. This stops aquatic hitchhiking. So when we get in a stream, we're wearing our waders or our tall boots. We have to use Alkanox to clean off our gear and everything that touched the water. So the gear decontamination can stop species from being transferred. So Didymo is the main thing that we don't want to be spread from stream to stream. And there could be zebra mussels or hydrilla. So these are all invasive. We don't want to take it from one stream and bring it to another healthy stream or anything like that. So deconning is very important at the very end of your stream assessment. And here's a picture of me deconning after a stream assessment. So I just wanted to include a few pictures of what the stream assessments look like and the decon. So this picture up here is people, the ambassadors doing widths, collecting. Here's pictures of the ambassadors sorting. This was actually taken at Rosedale, this picture down here. So sorting, looking for the macroinvertebrates, and then at the very end, making sure that we decon. Okay, so I did just want to put a picture of the map of Rosedale Park, where to park if nobody knows. So when you go on Federal City Road, you go onto Rosedale Park that way, and then you pass that big playground and that first parking lot, and then you go down to that second parking lot, and Stony Brook is right there, and that is where we are going to be meeting on Saturday. If it also helps for anyone that still may not know where they're going, please take a moment to just write down these coordinates. You can put the coordinates into your GPS or Google Maps or anything that you use for direct to the parking lot where we are meeting on Saturday at 10. I'll just leave it up for a couple minutes in case anyone wants to write it down. Just because I know when I put in like Rosedale Park, it doesn't take you exactly to this parking lot or this parking lot. So I just want everyone to make sure that they are good to go Saturday and 10 a.m. sharp.
Awesome. Thank you so much, Amanda,
Yes,
for giving your presentation to us. It was really, really great and so thorough. And I really want to ask participants to be engaged. So in the Sourlands, if you don't already know, we're going to be losing 1 million ash trees over the next few years due to the emerald ash borer. And this is going to have a catastrophic effect on our streams. Trees around the stream banks, they hold in those stream banks. And so if our trees go, our stream banks go. The trees also on the stream banks, they filter nutrients entering into that stream from the road or any other inputs. And so you're going to get more nitrogen and phosphorus into your stream, which will cause eutrophication problems, algal blooms. I don't know if any of you heard about all the harmful algal blooms last year they had. That is because of nutrients entering into the stream body. Another thing that riparian trees do is that they shade our streams to keep the water cool, and cool water holds more oxygen and more organisms can live in that cooler water. So there are so many effects of us losing our canopy from the emerald ash borer. So getting out now and finding out what the state of our streams are right now is really important, so we can track what's happening over the next couple of years and try to mitigate that. By becoming involved in stream monitoring, it literally puts eyes on the ground. A lot of the sites and streams in the Sourlands are not monitored by anybody. So we really depend on volunteers to come out to these events, learn how to do it, and then go out with Sourland Conservancy folks, or going out with a Watershed ambassador, and giving a hand and helping us, collect information, sort macros. So, I really would love it if you go out on Saturday and you're like, this is awesome, which it is. I've done many of these, training sessions for the last, I guess, 4 years. I think I've attended 12 by now, and they're always fun. Like, it is always so much fun. So come out, have a good time. And then if you're really drawn in, please let me know. I would love to have you come out with me and some of our other stream monitors and go out and, make a difference in your local ecosystem. So thank you again, Amanda. It was really wonderful having you. I look forward to Saturday, and I'll send a reminder email with the location for everybody.
Yeah. Thank you so much. I did just want to answer one question in the chat. I forgot to say if there's any questions. Yes, I think we both did. It's okay. So damselflies, can they lose their paddle-like gill and survive? Yes, they can. So just like the mayflies, and stoneflies, if they lose a tail or two, they can still live. Even because it is their gills, they may just be struggling to breathe a little bit, but I have found damselflies, stoneflies, and mayflies all with either missing tails or missing gills, and they're still moving and grooving. So yes, they can survive. But if there's any more questions, yes. Should we bring anything besides waders and water? Maybe a snack. I think we might take a break. I don't know how long of a break, Carolyn. I don't know how long the first one was for Cameron, but we could definitely take a break. Probably around 11.
Yeah, you probably go.
So bring a snack, anything. Yeah, sounds good. I don't think if you have hip waders, I think just maybe even tall rain boots would be fine for this stream. It doesn't get very deep, so I think it should be fine. And there is extras for people that don't have any waders or don't feel comfortable with just their tall boots or anything. Yeah, so water, waders, there is extras if you need them, a snack or a lunch to hold you over. I think
maybe a hat, sunscreen.
Yes. Sunscreen, bug spray, all those great things. But yes, if there aren't any more questions regarding Saturday or about the bugs, that's it for me.
All right. Well, thank you again.
Bringing the supplies.
Yes, no problem. And thank you guys for having me. This was really, really great. I'm so excited for Saturday to get out there and I get to show you guys what I get to do for being an ambassador. So super excited.
All right. Take care, everybody.
Thank you. Have a great rest of your night.
You too. Thank you.